Good day to you students. It is Mrs. Humanek here, and we are going to be going over the first 2 pages in the packet today. So before I get started, I want you guys to take a look. These are these first 2 pages. They're simplifying radicals, and so if you need to go ahead and pause the video and stop and go download this sheet from your teacher's Canvas course, please go do that now. Otherwise, let's go ahead and get started. So before we get started, we are talking about simplifying radicals. But my question for y'all is, what is a radical? All right, guys. Now, a radical is very simply, it is this symbol right here. All right. It means that we will take the root of something. So I don't know if we can see that well, so I'm going to change my color. So it's this symbol right here. You have probably known it more often as a square root. So we are going to be talking about that today, and but we will call it a radical because we will learn that you can also do some other things with it, like take a cube root or a fourth root. But today we're going to be working on taking the square root. But this symbol right here is our radical. All right, so we can say, for example, if I said square root of 25, we know that that would be 5. We could also say radical 25 is equal to 5. All right? So that is, the first kind of thing. So we're going to go ahead and dig into the notes here. So what I want us to look at is simplifying these radicals. So before we do that, before we do any simplifying, it's a really good idea to memorize these perfect squares, all right? So if you take 1, then 1 squared would simply be 1, right? If we did 2, 2 squared would be 4, and so on. So what I want you guys to do right now is I want you guys to go ahead and pause the video, and I want you guys to fill out the rest of this chart here. And if you wanted to grab a calculator, you could do that. You can simply, oh, my batteries are a little low. You can go 3 squared, and we know that that's 9 if you don't know that off the top of your head, all right? Hopefully you know some of these in the earlier columns off the top of your head. These guys over here you might not know off the top of your head. So I'm going to go ahead and pause, and I want you guys to go ahead and pause and fill out the rest of this chart here, all right? And you can do it with a calculator, and you can do it a couple different ways, like I just did with 3 squared with the little button. Where's the square button? There it is. It's right here on the calculator. You can also just do 3 times 3 if you want to do it that way, because when we square something, we're just multiplying it by itself. And so you can do it that way, and you can so on with the 4, 5, 6, 7, 8, 9. All right, so go ahead and fill that out. All right, guys, so I'm coming back to you with this completed. So we have, so I've completed my chart. Honestly, you guys probably know a lot of these already, but it's just good to remember and just go through them and try to commit them to memory. And so we have 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and 15 squared is 225. All right, and so it's good to have those in your memory and have them recognizable. And what's nice about this is now we can also know that we can work backwards, right? So if we take the square root of 16, we would get 4, all right? If we take the square root of 64, we would get 8. So now we're going to go ahead and find the value of each of these. And guys, I'm going to teach you how to do this without necessarily having a calculator, but know that you can always use a calculator as well to find your square roots and do that, okay? So we know on number 1 here, this is a nice good example. We know that the square root of 25, if we look back up our chart here, we know that the square root of 25 would be 5, all right? But I want to show you guys how to actually break this down so that it is a little bit more, just so that you can do it even if it's not an easy answer, all right? So if you wanted to break this down a little bit more easily, or I guess more simply, is we know that the square root of that 25 has the factors. We would go ahead and factor it out, and we know that 25 is 5 times 5. So if we rewrote that as 5 times 5, we can write it, because 25 is 5 times 5, so that's under the radical. And here's the deal, guys. Whenever we are factoring out out of our square roots or out of our radicals, because it's square root, we want it to have a pair. So we know that since they're a pair, we can go ahead and take them out together. So then it would be equal to 5, and there would be nothing left inside of the radical. Now these are, everything on this page is going to work out really nicely and perfectly, and so there will be nothing left inside the radical. Now this seems a little bit complicated for this problem, but it will help as we keep going. All right, so let's go ahead and look at number 2. So number 2 is 169, and if we go back and we look on our chart, we see the square root of 169 would be 13, right? So we say, okay, we know the answer's got to be 13. But what we can do here is we can, if we go ahead and factor this out, we see that it is 13 times 13 is what makes the square root of 169. So if we went ahead and rewrote this in expanded form, we could say that it's not just the square root of 169, but it's the square root of 13 times 13. And what we can do is we can take this and it comes out of the radical. So that means it would be equal to 13. All right, so we're going to go ahead and move on to number 3. Now number 3 is going to be a little bit different than 1 and 2 because it has a negative outside of the radical as its little coefficient here. So now here's the deal. I actually, I don't necessarily know this off the top of my head, but what we can see is we can actually, work with it here on the calculator, right? And so if we go ahead and say, okay, you can actually use the square root button. And so where you find that on your calculator is you hit second, and then instead of the x squared, we do the little square root. And you could type in 441. And then when we hit enter, we see that the square root of 441 is actually 21. So we know that the factors of 441 are 21 and 21. So if we rewrote this, we could rewrite it as the negative square root of 21 times 21, okay? But if we take this and because when it has a square root, it needs to have a pair. We see 21 times 21, so we take that pair out, and we are left with negative 21, right? Because we took the 21 out, but we can't just get rid of the negative. So the answer for this problem is actually going to be negative 21, all right? So we can't just lose that negative. Now let's see what happens over here on number 4. So we see that the square root of 144, we can know that from our chart. The square root of 144 is actually 12. And we know that that would be, 12 and 12. So if we rewrote this, we could rewrite it as 2 times the square root of 12 times 12. So what we can do is we can take our 12 out. Whoop. And so what we are left with is we are left with 2 times 12. Now when you have a pair, it is 12 times 12 on the inside of the radical, but when you take it out, there's only one 12 left, all right? And so what we are left with is 2 times 12, which is 24. So our answer would be 24. All right. Now let's take a look at these. And so I'm actually going to stop doing the factor trees on these guys down here so that we can see what we do here. So these guys, we have some fractions on number 5, all right? So we have the negative square root of 1 over 64. So how I would want to rewrite this is I would want to rewrite this as negative, and we're going to separate our radicals here. Square root of 1 over the square root of 64. And what that does is then we can treat each one individually, all right? So what we are left with here is we keep our negative, and what is the square root of 1? Well, the square root of 1 is simply just 1. And the square root of 64, we can know from looking back up at our chart, or we can type it into our calculator, is 8. So we have negative 1 over 8. So our final answer would be negative 1/8. All right. Now let's take a look at number 6. This is the square root of 169 over 225. So if we wanted to rewrite this, we can rewrite it as the square root of 169 over the square root of 225. And we know from our chart or from our calculator, the square root of 169 would be 13, right? Sorry about that. It's going to change my color. And then the square root of 225, we know from our chart or from our calculator, is going to be 15. So that means our final answer would be 13 over 15. All right. Now, let's take a look at number 7. This one's fun, all right? So, what we have is we have 3, right, on the outside is the coefficient to our radical. So we have 3 times the square root of 361 over the square root of 576. All right, now these are not on our chart, and so what I would recommend doing, the very first thing that I would do is I would always see if there's a good square root of this. So what I'm going to do is I'm going to type in the square root of 361, and we see that that is equal to 19. So first of all, we can't just get rid of the 3, right? That's really, and when we have a whole number like that, we can say that it's like 3 over 1. And then the square root of 361 was 19. And let's see what happens. Oops, sorry, it's a little shiny. The square root of 361 is 19. And then the square root of 576 is 24. All right, so we can do this here, and we see that. So now we're not quite done yet because we still have to multiply. So if we reduce this radical, it's 19 over 24. But now we need to go ahead and we need to make sure that we can simplify, right? So you can do this a few different ways. You can just multiply across the top and multiply across the bottom. Or you can also simplify your fractions, right? We know that 3 can go into 24 8 times. So we can go here, 1 and 8. So it would be equal to 19 over 8. That would be our simplified, the most simplified version of our fraction, okay? So the answer there, whoops, I'll do it in blue, would be 19 over 8. All right. So now let's take a look at number 8. All right. So we have our negative 4. And then I don't know what the square root of 484 is, so let's do it. I don't know it off the top of my head. And it is 22. All right. So we have negative 4, and then the square root of 484 is just 22. So negative 4 times 22 would give us negative 88. So our final answer is negative 88. All right, guys, so these are the first 8 questions, and then we're going to go ahead and look to the next 8 questions. All right? All right, on these next 8, we are going to talk about when the square root of a number that is not perfect, because not everybody is perfect. And so, guys, when you find a square root of a number that is not a perfect square, you have an irrational. All right? Square root. Irrational square roots can still be simplified, and we are going to teach you how to do that today. And you can do it a few different ways. You can do it by finding the perfect square, or you can doing it by the prime factors, okay? So we are going to go ahead and take a look at this. So let's take a look at 92. I'm going to do this first one by finding our prime factors, which means that we will use a factor tree to reduce it as much as possible, all right? And then we will also talk about how we can do it a different way, because it kind of depends on each person, on what they look. So if we looked here and we looked at our 92, and I said, okay, what's the square root of 92? Let's plug it in the calculator and see. Well, it gives me this horrible irrational number, right? So we know that it's, bigger than 9, less than 10, but it's not a perfect square. So if we wanted to figure out how to simplify this well, and what we can do is we can do it by prime factors. So the very first thing I would do is I would use my factor tree here. So the factors of 92 and 46, what I would do is I would use 2, because that's easier to me, right? And so that would be 2 and 46. And I would factor tree it again, and I would write it as 2 and 23. And so we cannot factor 2 anymore, we can't factor that 2, and we can't factor 23 anymore because they are all prime factors. So these are our prime factors. So if we were going to rewrite this problem, we would rewrite it like so. So we have our square root, and then I'm going to write all my factors in here. So we have 2 times 2 times 23. All right, and so we see that we have a pair here, so we can link up those pairs together. And when you take it out of the square root, only 1 survives. So this final answer would be 2 square root of 23. We can take the 2 out, but there's still a 23 that's left in here. So our final answer would be 2 square root of 23. And what you guys can see on here is if we have the square root of 92, we have 9.59166, yada, yada, yada. But if you have 2 times the square root of 23, we should get the exact same answer, because it is 2 the square root of 23 is just the square root of 92 simplified. All right? All right, so let's take a look at number 10. Now, for number 10, what I want you guys to do is we are going to actually try, rather than doing it into the prime factors, I'm going to show you guys how you could do it with a perfect square, finding those perfect squares. And so instead of doing it, to the very, very to the primes, I would look at this one. I would say, okay, this is the same thing as 4 times 6. Now we know that 4 is a perfect square. So how we can write that is we could rewrite this problem as the square root of 4 times 6. And we know that the square root of 4 is, and so how we can rewrite that is we can rewrite it as the square root of 4 times the square root of 6. And we know that the square root of 4 is 2. So we can say that it's 2 square root of 6. So that is our answer here. If you wanted to do it through perfect squares. Now, if you wanted to reduce it all the way to the prime factors, you could do that as well. The 4 would go to 2 and 2. The 6 would go to 2 and 3. All right, and so we would be left with all these prime factors, and you could rewrite it as 2 times 2 times 2 times 3. And you have to find partners, and so these 2's are partners with each other, but we're left with a 2 and a 3 still in here. We pull out our 2, so we would have 2 times the square root of 2 times 3, which is 2 the square root of 6. So those are 2 different ways to do the same thing, all right? And so some people would prefer to do it by the prime factors and always finding your pairs. Some of you guys might prefer to find those perfect squares that are the factors and then do it that way, okay? So let's take a look at 247. All right, number 11, the square root of 247. So we need to find some numbers that can divide into 247. So how I'd recommend doing this is I would recommend having a calculator out, whether you have a calculator in person, or you can use your phone, or you can also use desmos.com. There's a lot of different things. So as you're going through, you're like, okay, 247, you know it's not going to be divisible by 2 or 4 or any even numbers. So we know it's not 5. Is it divisible by 3? No. Okay, so you can kind of go up and you can try to guess some numbers here that it might be divisible by. We know it's not going to be divisible by 10 because it doesn't end in a 0. Let's see if it's divisible by 11. No. 247 divided by, let's try another odd number. 13. It is. Lovely. All right, so 13 and 19 would be our factors here. So we take 247 and we say, okay, 13 and 19. Well, guys, 13 is a prime number. Nothing's divisible by it. And 19 is also a prime number. So we're done, right? So here we are. So this ends with 13 times 19. So there's no pairs in this one. So this one you cannot simplify. You cannot simplify this one. So this one is already reduced. So the answer to this is just the square root of 247, all right? All right, so let's take a look at number 12. All right, so the first thing I would do, and I forgot to do this on 10 and 11, but the first thing I would always do is go ahead and check and say, okay, is the square root of 92 a perfect square? No, it's not. It's irrational. So we've got to go ahead and use our method here. And so what I would do for this one is I would go ahead and let's factor tree 192. And so I'm going to reduce it to its prime factors. So I'm going to say that would be 2, and 192 divided by 2 would be what? 96. And then 96 is 2 and 48. 48 is 2 and 24. Then we have 2 and 12. Then we have 2 and 6. Good night. And then we have 2 and 3. That is a lot of 2's. So I'm going to go ahead and take all these guys. Those are all of our prime factors. Okay, so if we were going to rewrite this, how we would rewrite it is we are going to rewrite it with all of the factors. So we say -3, radical. And instead of 192, we're going to write all these lovely prime factors. So we are going to say 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. 6 2's times 2 times 3. All right? So we have all these lovely little factors here. Okay? And what we are going to do is we are going to find the pairs. That's 2 times 2, so we can pull that out. That's 2 times 2, so we can pull that guy out. And that one's 2 times 2, so we can pull that 2 out. So what we are left with is on the outside of the radical, we have our -3, right? We never lost that coefficient. And now on the outside of the radical, we have 1 2, 2 2's, and 3 2's. And we still have our radical 3, because that guy was on its own. So we have -3 times 2 times 2 times 2, radical 3. And if we go ahead and reduce that, that will turn into -24, radical 3. All right? So that is what it looks like to go ahead and do it with the factor tree. All right. Now, if you wanted to see what this problem would look like if we did it with our perfect squares, I'll go ahead and do that for you right now. Okay, so let's take a look at this. So if we said, all right, so we have -3 and then square root 192. So what I would do, let's hope we get -24 times radical 3. So we want to think about the perfect squares that can go into 192. So if we know some of our perfect squares, we know, and we want to think about the biggest perfect square that can go into it. So what I would do is I would pull my calculator out and I'd say, okay, well, 192 divided by 4. We know that's a perfect square. 48. Okay, that's pretty good. Let's see if we can do better than that. So 192 divided by, what's another perfect square? 9. No, that doesn't work. All right, 192 divided by, let's say 16. Hey, that's a pretty good one. But let's try another one. Let's see here, 192 divided by, let's see, let's try 64. And we get 64 and 3. So that is the largest perfect square with that little prime number right there. So what we see is if we have 64 and we have 3, that is going to give us a nice big number that is a perfect square, that's 64. And so if we were going to rewrite this, how we could rewrite this radical is we could rewrite it as -3 radical 64 times 3, because those are the two factors there. So if we were going to, and so we could rewrite it again, we could say, okay, -3 times radical 64 times radical 3. We can separate those guys out. And so what we would be left with is we would be left with -3 times 8 times radical 3. Well, -3 times 8 is -24 radical 3. All right, guys? So if you wanted to think about it in terms of the perfect squares, you can also do it that way right there. All right, guys, we have 4 more left, so I'm going to go ahead and do these with you guys right now, and I'm going to go ahead and think about them. I'm going to do the rest of these in terms of the factor trees, so to speak, and reducing them into their prime factors, all right? So let's look at 63. So 2 factors of 63, if we think about it. 63 divided by 3 is what? 21. So we have 3 and 21, and then 3 and 7. All right. And so if we wanted to rewrite this, we could rewrite it as the square root of 3 times 3 times 7. Oh yeah, I didn't circle my prime factors. Sorry about that. 3 times 3 times 7, and we see that 3 and 3, those are pairs, so we can pull those out. And that would become 3 radical 7. And it would simplify into 3 radical 7. All right? Over here, for 98, let's go ahead and do our prime factors. We would have 2 and 49, and 2, oh no, 49 is not divisible by 2, silly. But we have 7 and 7, and so that's a prime factor. 7 cannot be reduced, and 7 cannot be reduced. So we would go ahead and we would rewrite it as 2 times 7 times 7, all right? And we know that 7 and 7 are the pair this time. Pull that out, and we are left with 7 radical 2. Okay? And then for 15 and 16, let's take a look at these guys. We're going to go ahead and use our little factor tree here. So we have 5 radical 72. So first I'm going to do my factor tree for 72. And I would say, I think the easiest way to start is just with 2. So it would be 2 and 36, and then 2 and 18, and 2 and 9, and 3 and 3. So we are left with 2, 2, 2, 3, 3. So if I was going to rewrite this one, remember we don't want to lose our coefficient, so it would be 5 radical, and then we're going to write all of our lovely factors in here. So we had 2 times 2 times 2 times 3 times 3. So I'll pull this 2 out. I'll pull this 3 out. And we are left with 5 times 2 times 3 radical 2. That one lonely 2 is still inside there. So then we have 5 times 2, which is 10 times 3. So we have 30 radical 2. That's our answer right there. All right, and it's super important to remember that when you have a pair inside the radical, when you take it out, only one of them remains, right? The other just doesn't make it, it disappears. All right, and our last one, we have 2 times 48. And so the first thing we're going to do is we're going to factor out our 48. So that would be 2 and 24. And then 2 and 12, 3 and 4, and 2 and 2. I guess I could have done 2 and 6, but I did 3 and 4. So that's okay though. We got to our prime factors. We have 2, 2, 3, 2, 2. So if we were going to rewrite this, we can't lose our 2. Remember, we don't want to lose that coefficient, so it becomes 2 radical. Make it a little longer. And it's 2 times 2 times 3 times 2 times 2. So these are little partners that we can pull out, one of them out. These are little partners. Pull that guy out. And we are left with, we can't forget our original 2, so we had 2 on the outside, and then we had a 2 from this pair, and 2 from this pair, and then we were left with that radical 3. That was all alone. So 2 times 2 times 2 is 8 radical 3. Okay, so we are left with 8 times radical 3. All right, y'all, so this is how we can simplify our radicals. Now, I'm going to go ahead and I'm actually going to rewrite these guys real quick. You can go ahead and pause it, but I'm going to go ahead and do these 2 up here with the perfect square, just to see, just so you guys can see a different way to do that. But if you if you feel good about it, then you can go ahead and get started on your homework. Otherwise, you can stick around and kind of see how I do number 13 and 14 as perfect squares. All right. So here we go. For number 13, I'm going to go back up and I'm going to do this guy as a perfect square. All right. So let's take a look at these. And so what I want to think about is I want to think about the 2 factors for number 13 that are where one of them will be a large perfect square. And what we can see is we know that 63 can be factored by 9 and 7. And we know 9 is a perfect square. It's this, and so the square root of 9 would be 3. So how we can rewrite that is we can rewrite it as 63 times 7. And if we separate that, oh, not 63 times 7. Oh my gosh. Sorry about that, guys. So that would be rewritten as 9 times 7 instead of the square root of 63, which we could rewrite as the square root of 9 times the square root of 7. I'm struggling a little, sorry y'all. Square root of 9 is 3 times the square root of 7. All right, and so that would be the exact same thing. So if you prefer to do it with the perfect squares, that's a great way. And if you look at number 14, we could rewrite 98, if we want to think about all the perfect squares that it could be, if we go back to our, original little chart, well, it has to be smaller than 98, right? So, a good method to do that is if you said, okay, 98 divided by 81, clearly that's not it, right? 98 divided by 64, okay, that's not it. But 98 divided by 49, that does give you a nice even split there. So we have 49 times 2. So that means we can rewrite the square root of 98 as 49 times 2, or you can rewrite it as the square root of 49 times the square root of 2. Well, we know that the square root of 49 is 7, so that would be 7 times the square root of 2. All right, so if you prefer not to do it with the prime factors and making that little factor tree, then you can also do it with these perfect squares. So good luck on your homework, and don't forget, you can always check your own answers, right? If we go here and we see that the square root of 98 is this, then we want to check that, and we want to say, okay, 7 square root of 2 would give me the exact same irrational number. All right, guys, so you can always check your answers. We can do it for the 63 one as well on your calculator, and so that would be 3 square root of 7. And so you can see that those are the exact same irrational number when you actually check it. So anyway, I hope that you guys were able to learn a little bit some new things about simplifying radicals, and we will see you next time. Bye.